So you're good? All right. Kristen already gave you all a background on my work. As you mentioned in the content that was sent out, there's going to be sort of two big aspects to this talk. We're going to be focusing on hiring your first members as well as building a basic analytics stack. In terms of asking questions, time to talk, it's roughly like half an hour, so we should have about 20 minutes of Q&A at the end. We can ask questions then. However, if there's anything that I cover and you don't understand it and you feel like it will lead to you sort of like not being able to understand the rest of the things that I'm saying, by all means, please, either just like unmute your mic and say something or raise your hand, Kirsten. I'll rely on you to let me know in that case. And I'm happy to stop and explain before moving ahead. Odds are that somebody else has the same question, so don't worry about that at all. But we will also have Q&A at the end for just general questions. So are we good to get started? Cool. Kristen, could you pull up the first poll? So before we get started, everybody, want to do a quick poll where I learn a little bit just about what stage of the startup lifecycle you're currently at. Are you pre-product? Are you developing it pre-launch? Are you beta or wide release? And this just gives me a better sense of who I'm talking to, and I can customize what I'm saying a little bit better.
Excellent. Looks like we already have 9 folks filling it out. So if you haven't filled out the poll or don't see it, let us know. I'll give it a few more seconds and then I will show you the response.
Yeah, I'm actually not sure if it'll like show me the response while I'm sharing my screen because I can't see the poll itself. But I'll let me know when you've shared it and I can tell you.
Okay, so I've shared the responses. Can you see those, Ali?
Yeah, I can see it. Oh, wow, a lot more wide release than I expected. Interesting. Cool. That's good to know. That's exactly why I want to do this poll. Great, thank you very much. And then we're going to do one other really quick one, and this is just so I know what you have in place already. And that's, just let me know which one of these analytics components you already have implemented. And if you don't know, then just say not sure. That's totally fine. But it would be nice to know which ones you have.
Okay, we'll just give people a few more seconds. I think we have 5 respondents so far. Beautiful.
It's really fine to go with a not sure if you're uncertain about this. This is a little bit more detailed.
Cool, excellent. We'll end the poll and here you go. All
right. Okay. Yeah. So business intelligence tools, we got very few. Analytics database. Guessing you're not super aware of that one. Okay. And we got some dedicated data team members. Cool. More than I thought. All right. Well, let's get started. Thank you very much for your participation there, everybody. We'll get going on the content now. So jumping right in, the big question is always sort of, when should I start working seriously on analytics? There's no one correct universal answer to this, but the rule of thumb that I always say is when you're nearing product launch, because that for most cases, for typical cases, that tends to be when you start getting data coming in. Whether it's the wide release or beta, it depends on the breadth and depth of it. If your beta is just like 50 people, 100 people, and you're sending them, say, surveys afterwards already, then you probably don't need additional analytics work. But if it's 2,000 people and you want to look at their customer journey, then that's a little bit different. You very likely do. The beginning of the analytics stack is something that the vast majority of startups don't get right. I have my own theories about this. And when I say startups, I'm even talking about ones that I know that are like overvalued over $1 billion. And I've talked to, and they would have benefited greatly from the contents of this talk. So regardless of where you are in the early stages, I would say there's definitely going to be something for you to take away. And if you get this early stages right, it'll definitely pay you back many times over in time and work saved. So we're going to go straight into the single most common question that, oh, Cynthia's bouncing. All good. Later, Cynthia. So we're going to do the single most common question that I get when it comes to roles on a data team, and that's what's the difference between a data scientist and a data analyst? This is a super important one because if you don't get this right when you're doing your hiring, you'll end up paying extra and spending a lot more time looking for people than you need to. The important thing to keep in mind is that data scientist isn't just a catch-all term for anybody who works with data. It refers to a specific niche of data work, specifically people who work with predictive models using machine learning techniques. Now, in regular conversation or that kind of thing, if you want to just call everybody a data scientist, that's fine. But when it comes to putting up a job listing and writing a job description, it's really important that you get the title right. And we're going to go over why in just a bit. So, a data scientist does that kind of work. A data analyst typically does like building up dashboards, like the KPI dashboard, analyzing data, building new tables that both them or the data scientist might use. So sort of a broader and more fundamental type of work than a data scientist. We're going to go over a couple of examples so you can see exactly what that means. Let's take Spotify, one of my favorite products. I think most people use it, if not everybody on this call. They have this feature called radio. Let's take that. For those of you who may not be familiar with it, the radio feature is where you basically select a specific track and you're like, hey, start a radio off of this. And it generates a full playlist of songs that are similar to that it's recommending, and it's guessing that you're going to like those based on the first one that you selected. So it's a really useful feature. I've discovered a ton of good music from it. So around that role specifically, the data scientist is the person who builds the model that recommends which tracks to add to a playlist. There's some recommender system underneath powering that. The data scientist builds that. The data analyst gets asked questions like, hey, how many people are using the radio feature in general? Or like, what's the average length of a listening session that stems from a radio playlist? And they have a couple different ways of answering this. They can either build a dashboard that monitors these numbers over time, so it's just like a long-term solution, or they can do like a one-time analysis. But that's typically the type of question they try to answer. And another example would be Netflix. I mean, everybody's used this one. Let's just take the Netflix homepage when you get there and, scrolling around trying to find what to watch. A data scientist, again, is building the model that recommends all those shows to you. I'm sure you all noticed that like your homepage and somebody else's homepage look different. It's because the recommender model is deciding based on what you've watched before and what other people have watched, like what they think you would like. So that model is built by the data science team. But the data analyst team then answers questions like, hey, how much time do people spend on the homepage before like choosing a show? A time that Netflix probably wants to get down over time, or like what's the most common category that starts a viewing session? Is it comedy? Is it drama? That kind of thing. The reason why it's so important to get this difference is that data science are more expensive and harder to find. But again, I want to emphasize this. That does not mean that they're just generally like better. They're just more specialized. You want to get each person for the job that they are good for. A rough analogy here for those of you who say are more familiar with engineering hires would be, I don't know if this is still for sure the case, but there was definitely a time when like infra and backend engineers were more expensive than front-end ones. Getting a data scientist for a data analyst job is basically like getting an infra and backend engineer to do a front-end engineer's job. It's like you'll end up paying more and they probably won't do as well, because it's not that one is better than the other. It's more just like supply and demand and specialty level. And so a couple of tips around this, I would say that unless your core product is powered by machine learning, which based on the intros we did, I think only one company here who's doing geospatial analytics would be potentially in that crew. So unless you're in that group, your first hires should very likely be data analysts and not data scientists, because they just cover a broader range, and your early questions tend to be much more something that they can answer as opposed to asking somebody to build a predictive model. And in these typical cases, rule of thumb again is that I would say a rough ratio of analysts to scientists on a team would be like 3 or 4 to 1. So 3 or 4 analysts for each one scientist is about what I've found to work decently well and what I've seen in big companies. There's a lot of other titles and more titles popping up around data roles. I put this Venn diagram together myself using sort of the 3 big disciplines of technical data work, which is data science, engineering, and analyst, to give you a sense of sort of like where the other titles come in. So, when data analysis and engineering are sort of combined, you get an analytics engineer. This is a title that's becoming much more popular now. The combo of science and engineering is what machine learning engineers are. And then the combo of analysts and scientists, I still just call a scientist, because data scientists need to be able to do just some basic data analysis for their work as well. So generally speaking, I would say, again, if you're not part of the crew that has like machine learning as their fundamental product, you likely just need a data analyst, or if you want to get a little bit adventurous with it, go with analytics engineer. But those are the only two titles that I would suggest you use. Other ones like BI developer or like, business intelligence engineer, those are more specialized ones that big companies like Amazon and them need. But at the early stages, you just need the broad ones, not hyper specialized ones. All right, so that covered the that sort of like hiring section. Now we're going to talk a little bit about basic analytics stacks. There's a lot of different tools in the market, a lot of different things that you can add, lots of bells and whistles, but there's three main components to each stack in my mind. There's the analytics database, that's tools like BigQuery and Redshift. There is a business intelligence tool like Looker, Tableau, Google Data Studio, that kind of thing. And then there's also like product intelligence tools like Mixpanel and Amplitude, which, if I recall the poll results correctly, like the category 3 here was the most popular that you've had in place already, followed by BI tools and then analytics databases. So what is an analytics database? So the people who mentioned that they have BI tools very likely have this too. They just may not have been aware of it. But this is a very important component of your stack. It's basically a replica of your product database that's used solely for analytics purposes. So why is that? And what does that mean? Your product has a database that it interacts with constantly, right? It every time a user creates a new account, it adds a row in in a users table or a key value pair or something that stores that user's information. And every time someone pulls up their profile, it goes to that table and it pulls their information so it can display it to them. So the product and this database are constantly like reading and writing to and from it. But then analysts and your internal analytics team, whether they're scientists, analysts, whatever, they are mostly reading from the data from a database, and they're doing these really large volume queries. If they were to access the same database that your users, your product essentially accesses, it would really cause problems because it would slow it down. And you obviously don't want that. You don't want your users to not be able to use your product well because your analyst is running a really large query. So what we get is this other component, which is an analytics database that is just like a copy of your product one, that is used solely by your internal team. And this is it's not an exact copy of it in that it's a differently configured database. It's a different type of database, but it contains generally like all the same information, and it's usually replicated over through a process that runs anywhere from every 5 minutes to every day. So you can have it hourly, daily. The more frequently it copies over the information, the more up to date your data is going to be when you're running analytics. And so whatever cloud service you have built your engineering stack on, it offers analytics databases too. So the most famous ones being like Amazon Redshift is their data warehouse. Google offers BigQuery, that's their big one for analytics. And so if you use either of these, that means you have an analytics database. And using the same cloud service that your engineering stack is on, your product database is on, for your analytics one, tends to make the process of that replication process and that setup process kind of easier, but it's by no means required. You can definitely go cross-platform with it. It's a little bit more steps, but if you feel like the other platform offers something better for you, then that's fine, and you should do that. They both have services that work with the other one, so you can transfer data in. And they have APIs for it too. So like at BuzzFeed, where I was a data scientist, we had our product built on AWS, and we had everything in Redshift for like my first year. And then we did this big migration process and we moved everything to BigQuery for my second year. And the migration process was a bunch of work at the beginning, but it worked fine after that, and we were all very happy with it. And it was because basically BigQuery just gave us a better offer, so we were saving money on it, and we made the switch. So it's definitely doable. Moving on to component 2 of the basic stack, we have business intelligence tools, BI tools for short. And these are the ones that let you quickly build interactive visualizations and charts of the information that you have in your database. So Looker, Tableau, Metabase is one that's rising popularity now. Google Data Studio, Mode. There's a ton of these, and they all sort of accomplish the same general purpose, just with different approaches. The BI tool connects to your analytics database. At least that's how you're supposed to do it. That's why I said that whoever has BI tools probably has an analytics DB as well. And the choice of which one to use is really based on like your engineering stack, the pricing, like what your team is familiar with. There isn't one big good one. Just like one tip that I would give you here. And look, I don't, I have no dog in this fight. No one's paying me for any of this stuff, but I would just say, don't just default to Tableau. I hear that so much where someone's like, oh, we just need the data, so we defaulted to Tableau. That is definitely the most well-known name, but by no means is it the universal best option. Do some research, ask around, find companies that are similar to you and ask them what they've done. I personally, just my personal interest, I'm not saying go with this. Personally, I like Looker as sort of the most universal solution, and if you're early stage and on BigQuery, I actually like Google Data Studio the most. So just do some research and don't default to the most well-known choice, because I know a lot of people who have done that and regret that decision. Just a little tip from experience for you there. And then the third component is product intelligence platforms. That's the likes of Mixpanel and Amplitude. This was the category that you responded to the most in the poll, so I'm guessing you're the most familiar with. As you know, these are platforms that are focused more on the product itself as opposed to the business as a whole, which is what the BI tools focus on. They get their data from little code snippets that you insert into the product. They're from their own API. And so like, let's say you want to track a certain action in the product, like someone clicking the send message button in your app. You put a little snippet into the larger snippet of code that runs every time someone taps that button. And in that snippet, you give an event name like user tapped send message button and some information about the user, like, I don't know, were they on an iOS or Android, or how long they've been a user, a bunch of contextual information about them. And every time that snippet runs, it sends one data point to your service, like Mixpanel Amplitude, and it stores all of that in their own database. And then you get these tools on top of that that lets you cut into the data so you can see different things about it. So one question people have a lot of times is like, why do I even need one of these if I already have a BI tool, or vice versa? Of course, the product and the business are closely intertwined, so there's going to be some overlap, but they just focus on different things, and generally you end up needing both in due time. The business intelligence tool connects to your main database, and that database, usually just has the information that like your product needs to know in order to run. And so that leaves some gaps that these tools can handle really well. So an example would be, as Kirsten mentioned, I worked at Bird, the electric scooter company. I was a data lead there and a data analyst manager. So one feature that these Bird scooters had is what we called chirping. Get it? You would sort of like press a button and the scooter would make this beeping sound. And it was to help people find them when they were close to one on a map, but they couldn't see it. That information about how often like a chirp has been used or past instances of them, like they're not going to get stored in a database somewhere because it's just not super relevant. Like you don't need to see your history of total number of chirps. Like that's just not a useful information to have stored. But as a product manager, you might want to know, hey, is anybody actually using this feature? Like, should we get rid of it, or should we show it a little bit better on the page? And so putting a snippet in for that is something that like a lot of products like this can really capture, and a typical BI tool can't. So they're still very, very useful, especially in the early stages. And their common features are like charts, funnels. Charts just just charts. Funnels, which is like you look at multiple steps of a process and you see how the drop off is throughout that. And then retention analysis, which is just like your standard triangular retention table, which shows, hey, of people who have done X action, how often have they come back in subsequent periods and done similar action or a different one. Another key point here about these is that because they rely on manually and certain code snippets, and they need to be maintained, you should consider the data in them to be an estimate and use it more directionally than you would what's in your BI tools. First off, those 3 features that I mentioned, they get like 90% of the work done. They usually have like 20 different features, but the vast majority of your work gets done with like 3 or 4 of them. So don't get overwhelmed when you open these and you see like 20 different things. Like I don't use them either. As for the data in them, if in a world where you've implemented everything perfectly and never mess with it, yeah, the data in them is super reliable. But that world does not exist. It's not the one we live in. Everywhere I've worked, this happens. It's like, you'll have a snippet in there and then someone goes in to edit the code and make a new feature and they delete it by accident. Or someone makes a new path to the same action and that path happens to skip the snippet. So it just happens a lot that little things like that. And that doesn't make them useless. It just means that you should consider them more directional and estimate than what's in your database, which typically is like pretty correct. It's like if you look the users table in your database, like if someone hasn't made a user account, like it's just not going to be a row in there. And so it's like, it's generally a little bit more reliable, even though this stuff is a little bit more flexible. So just a little tip to keep in mind. It's okay that the data in them isn't perfect. You can still use it directionally. So let's do a couple of case studies. And let's start with helping hands. As Kirsten mentioned, that's how I met Pedram, who's currently a visiting partner at Pear. And it's a nonprofit that popped up early in the pandemic to deliver food and groceries to at-risk populations. I joined them, I think, a few weeks after they got started as their head of analytics and built out their stack for them from scratch. I'm going off of memory here, but I think roughly at the time we had 7 engineers, no analysts. We had a basic product launch, just a web app, and about like 1,000 users. So in that case, our cloud service was Google Cloud. The product database was Firebase. The analytics database was BigQuery, which, as I mentioned, is Google Cloud's analytics service. The BI tool was Google Data Studio, which is one of my favorites. But only if you're on BigQuery, because otherwise the functionality will be limited. And for product intelligence, we just used Google Analytics because we just had a pretty basic website and we didn't do a lot of event tracking. Note on Google Analytics, it's a little bit behind the times right now as a tool, especially for doing product analytics. So I don't really recommend it if you have a sophisticated product, you want to get deep insights. It's still nice because it's like free. You just put in a snippet and it gives you some information really quickly. So it's quicker to implement, but at this point, it's better for like marketing purposes and just getting that basic information as opposed to really digging deep the way tools like Amplitude, Mixpanel, and Heap and them let you do. So, just keep that in mind. And then a second case study is Bird, the company I was at before that. So, this is an extreme rapid growth startup, I think $2 billion valuation at the time. I think it was considered like the fastest growing startup in history. I don't know if it still has that title. It's an electric scooter sharing company, as you all know. Global logistics and supply chain issues to deal with, like a very, very vast problem set. This team, at the point when I left, it was like, again, I'm going off of memory here, but I think at least 50 engineers, probably much more, about 30 analysts, 8 data scientists, like 6 analyst managers, millions of users globally. So we were built on AWS. Product database, I believe, was Postgres. Analytics was PrestoDB, a service offered by AWS. We used Tableau and Mode for BI, Mixpanel for product intelligence. Google Analytics for the website, because the website like didn't do anything really. It was just like a marketing website, like it wasn't our main product. So it was enough to just have GA on there to tell us like which pages get viewed the most and where we get traffic from. And then these other three here, they're not things that I've covered, but I just want to let you know what sort of things that can get added to a stack over time. You don't have to worry about them right now. I'm just giving an example. We had a data catalog service called Elation. Data catalogs are basically, you can think of them as like customized documentation tools for your data. So knowing like which columns of which tables contain good data, what the definitions are. These are problems that you will for sure run into as you get bigger. Like the data gets really messy and people are uncertain about what to use, and you end up with like 3 different answers to the same question. When that stuff starts to happen, that's when you need to start thinking about getting a data catalog, or better yet, just do it as early as you can. For ETL, which is the process of sort of building new tables and taking data from one place and storing it in a different format somewhere else, we use Databricks. And for anomaly detection, we used Anadot. Anomaly detection are services that will tell you if there's been like a sudden spike or a sudden drop or just like a complete cutoff in the data stream. So this is very useful to us because we had a ton of different markets, a ton of different data sources. We didn't have eyes on all of them all the time. So a service like Anadot would tell us if one of them suddenly spiked for whatever reason that we were unaware of. It would basically like alert us that, hey, there's probably something wrong. Can you take a look here to see what's happening? So that's what a service like that was for. And at this place, I think we went through like 4 different analytics databases. I think we started with I think we were on Postgres at the beginning too, and then we went like Athena, which is also offered by AWS. Then we went somewhere else. Then we ended up with Presto. So look, change happens. It's the, what do they say? It's like the only constant. It's okay. We do what we can to get things right the first time, but ultimately it's inevitable that some changes need to occur because your needs change, your team changes, your startup pivots. And so it's a bit of a pain to switch from one platform to another, one provider to another, but it's not an impossibility. It's doable. So if it happens, don't worry about it. Like everything else, just roll with the punches. And then the last point that I want to make, and if you're going to take one thing away from this talk, if it's not going to be the data scientist versus data analyst form, which is like crucially important, let it be this. I really want to advise you all to make a data roadmap if you're serious about your analytics stack. Just like you need a business roadmap and a product roadmap, you need a data roadmap too. It's guaranteed to save you a lot of time and money and work and prevent you from oversight. And I'm going to give you a very simple framework here on how to build one, because usually when I say this to people, they're like, I'm not sure how to go about it. Don't overthink. A very simple framework is this. Lay out your business and product roadmaps, whether they're like timelines or docs or whatever, next to each other. And if you don't have a business or product roadmap, you should make one. That's the priority. Make those and then come here to the data roadmap. So lay those out next to each other. And go through and have like a third blank doc or timeline. That's your data roadmap, and take each of the important points on the business and product roadmaps and copy them over to the blank one. So if you have like you're releasing a new app or you're expanding to 10 new markets, whatever, just mark them on a timeline and the data roadmap, and list top 5 questions that you foresee yourself having at that point. So if you're releasing a new app, you're likely going to have questions around what's the most used feature of the app? Is the most important feature of it getting used? Which markets are downloading it the most? All these things. And think, hey, will I be able to answer these questions at this point in time using the stack that I'm supposed to have? If the answer is yes, good for you. More often than not, the answer is no. And if it's no, then go, okay, well, what do I need to do in order to be able to answer this question? And put those actions in your data roadmap. So if it's a new app and you don't have Amplitude or Mixpanel built-in to be able to see what features are used the most, then your action is, before the release of the app, implement event tracking using your product intelligence platform. That goes on the data roadmap. And remember, it has to be a little bit before the launch of the product or the expansion of the business that it starts. So if your app is getting released in 6 months, you want to start this process in 4 or 5 months and be done with it by the time the app goes out. Same thing for a new market. You want to make sure that you have information from that new market coming into your BI tool and your product. So, you make your data roadmap in a way that addresses both your stack and your team needs. That's one thing to keep in mind. So we talked a lot about tools, but let's say at some point you start needing to power certain aspects of your business with machine learning, and you don't have any data scientists there. So in your data roadmap, you need to include, hey, hire a data scientist that starts by this point, because this is when we're going to start building the product. So just keep that in mind. There's your stack and there's your team, and both of those need to go on your data roadmap, just like they would go on your product roadmap. All right, so that's it. That's what I had for you, Kirsten. If before we get into the Q&A, while this is sort of like fresh in your minds, can you pull up the sort of last and anonymous closing poll? I'd like to just ask you all to really quickly let me know which part of this talk you found the most useful. If none, then just say none. That's important information to me. Or if it was too long and didn't listen, tell me that too. It's the first time I'm doing this, so the feedback is very valuable for me, especially if it is honest. So really appreciate you doing that. And then we're going to jump into Q&A after this.
Great. You want me to share the results, Ali?
Yeah, go for it.
Yeah. Most people are loving data roadmap.
Oh, fantastic. Yeah, and Emily just asked in the chat if I can share an example of a data roadmap. So tell you what, I don't have one immediately with me, but I will mock one up and I will share it with you all first chance I get. I'll send it to Kirsten to send it to everybody else. That's a great piece of feedback. So it was data roadmap first and foremost, and then was it the analytics database after that?
Yeah, I downloaded the results, so I can send it to you. I think that was the second though.
Fantastic. Thank you very much. So yeah, I'll share the data roadmap example with you. I think that's a very good piece of feedback. I'll make one and I'll send it out to everybody. So yeah, I'd say that's it. So if we want to do Q&A right now, I know we got about 20 minutes. The floor is open. Kirsten, if you want to run the session, I'm happy to answer any questions anybody might have.
Yeah, absolutely. Yeah, feel free to just jump on in and unmute yourself if you have a question.
So earlier you were talking about, was it your product intelligence being kind of an estimate and to use it directionally, like when you compare it to like the data is actually in your database.
Mm-hmm.
Sort of at what point, like when those numbers diverge, for example, like user signups, like you would expect every sign up, well, you'd expect like your number of signups to match the number of users in your database, right? But like at what point when those numbers diverge, do you really go looking for a bug?
I would that's a great question. Sorry, did you have more to say?
Oh, no, that's all.
No, okay, yeah, that's a great question. There isn't sort of like one universal rule that I can give about it, but you usually find out about it when you see some anomaly there and you compare it to your database and you're like, wait, these are just giving me like just completely different answers. And that's the point where you start looking for it, or you see some unusual behavior, like you'll see a sudden change that you're not able to find an answer for. And that's usually when you find like, one thing that would happen for us is we would suddenly see like a conversion point, a conversion rate from one step of a funnel to the next like drop. And we would check to see if there's any product changes or anything that makes sense for that to have happened, and nothing really explained it. And that's when we would look into seeing, hey, is this an implementation problem or what? Because we don't really know what's going on. And I'll give you an example that happened at Bird. We had this event that would fire whenever someone would open the map at the just like when you open the app, it's like a map of all the nearby scooters. And the event would fire, it was like, I think map opened with scooters nearby. It was to tell us like instances where someone opens it and there is one near them. And initially the developer had built it so that it would check for like the nearest 250 meters or something. Like if there was a scooter, it would fire that. If not, it wouldn't. And then later it got changed to the visible map. So if it shows up there, it would fire and wouldn't. And we saw a sudden drop in conversion, I think, or like an increase in conversion. And we're all like, oh man, what's going on here? So we start looking around, we find nothing has changed in the product, nothing has changed in the business, we haven't opened any new markets. And then we look and we're like, oh, okay, the developer just changed the definition, it's just firing somewhere different now. And we found that, okay, that's the problem. So, usually just kind of like come across it when you see an unexplained change and you compare it to your BI tool. I hope that answered your question.
I actually have a follow-up question. Like,
Yeah,
at what point did you decide to add that anomaly detection tool?
Pretty late on, because we got into a point where we had so many markets and we needed immediate response in every market, because we had people on the ground who were going and picking things up and putting them they were picking up the electric vehicles, the scooters, and like putting them in a truck. And we needed to do that quickly. So we were at, I would say maybe the team was over like 20, 30 people, the data team alone, when we put that in. It's typically for bigger companies, because when you're smaller, it's like you can see all of your data streams pretty well. It's for when you can't keep an eye on your streams, and when the business is so rapid fire that a short disruption can really do revenue damage. Like if you're, I don't know, a social media product that's like blown up and there's a lot of people on it, and time spent on it is a super important thing. And so product uptime is crazy important to you. Like at that point, you definitely need anomaly detection. But early stages, when you can just have a dashboard and look at it, and like an hour delay doesn't cause a problem, you're fine. So maybe think about it like that. If you get to the point where having an hour response time for something is like too long, that's probably when you need anomaly detection.
Got it.
I got like maybe two questions. One is just around the roadmap and kind of the phase between not having an analytics database and actually having an analytics database. The last couple of gigs I've had, seems it's sometimes a difficult thing to get up and running. I think teams usually don't have a dedicated data engineer. They're worried about the initial integration and then the maintenance that happens as you add product features and you have to kind of adapt the analytics database. So you maybe talk a little bit about some like ways to maybe shortcut that, or tools that might that bridge them without lots of. And then the second is we're primarily focused on analytics as a growth driver, and so maybe just some ideas around how to set that up when we're really thinking about retention, acquisition, like churn, all that kind of like longer, more like growth related metrics versus product analytics.
For sure. So to answer your first question around sort of like guidance around the process of setting up the analytics database, one thing that I mentioned in the talk that can make things simpler is to go with whatever is the standard analytics DB of your existing cloud service. So what cloud service are you built on, if you don't mind me asking?
Yeah, it's not a standard one, so I think it's all, yeah.
All right, say that again.
We're not running a standard.
Okay.
We're not on like Google or Amazon. I think we actually have some servers in
Okay.
Some local servers somewhere.
Got it. So you can still look at each of these cloud services, and they have these like data transfer services that connect to things, and it's like they're trying to make it easy for you to put your data analytics database on their platform. So I would still look at them. I know Google's is literally just called the Google Data Transfer Service. I don't remember what AWS is called. So still look at them. They usually have their own built-in one, which is not as customizable as a script written by an engineer. And maybe doesn't run as quickly, like as fast, but it still works, if you want to get something up and running. So I would look into that. And like if that doesn't work either, then I would say just have one of your engineers like write a script that transfers it over, instead of like it's not if you have engineers that have been building your product and the back end of your product, they should be able to do this too. It's not something particularly crazy or advanced. Like it's a Python script and you run it on like a cloud function that just like gets pinged maybe every hour and just copies everything from one location to another. And there's a ton of documentation for it. So if you don't find an existing service, unfortunately, there isn't really an alternative besides having to write a custom script. It is what it is. But you did say that you have, am I recalling correctly from early on that you said you have a lot of information in Google Sheets?
Well, I mean, yeah, I'm kind of building my own little database. So we have a bunch of APIs, but I'm gluing together like I'm kind of creating my own relational database from some CSVs.
So if you have like, if you're keeping your Google Sheets data pretty up to date and you want like BI on top of that, then go with Google Data Studio. Google Data Studio connects with Google Sheets and it's free, and it works. So that's another thing that could potentially help you.
Yeah, that's what we're doing. So I think like where I'm trying to get to is yeah, obviously we're trying to automate all of that, keep it on a dashboard. So thanks.
Another little tip, by the way, if you you can set up BigQuery tables that are just a Google Sheet, essentially, and then you can use SQL to run it. If you didn't know that, it sounds like you do already, but that's another thing you can do potentially in that stack. And then to get to your second question, which was analytics that are more growth focused, I would say, marketing analytics are like a little bit of a different category of their own. There's like, attribution tools like Adjust and like a lot, product marketing tools like Braze in them, but they still use a lot of the same infrastructure that you would use for something like this. So for example, if you're tracking events for your product, especially if you have a tool like Segment that goes in the middle, that's like an event routing hub, then it's very easy to connect that to a tool like Customer.io or Braze or one of those, which then you use to connect to your users and increase engagement and get growth out of that. But generally, I wouldn't differentiate too much between things that are growth focused versus ones that are product focused. Like the same, a retention chart is ultimately a growth tool just as much as it's just like a regular product tool. As for acquisition, pretty much all of these services have ways where you can look at, if you're on the web, they can cut by UTM sources. And if you're on mobile, then you have to use a service like Adjust as an attribution tool in order to get that information in. But they combine with all of those, and you can get what you need out of them.
Awesome. Maybe a last question or two, and then we'll start wrapping up.
Well, I've got one. Hey, Ali, in a similar way to Bird, we need to forecast and match supply and demand based on location. And I'm wondering if there were any tools you found useful in analyzing location data. And by the way, I was a day back Bird user at one point. So
fantastic. Fantastic. Can you remind me again which startup you were with? Were you with Anycart?
So we're with Axel. So we're basically like a logistics platform for in-home healthcare.
Got it. And do you have, have you launched already and you have existing data in there about like which places you've had demand?
We do, yeah.
Right. So we didn't use a specific tool to forecast demand. We used our own the data that we got initially. Like when we initially like put things out, it was just by like people thinking, all right, where do we think there's going to be a lot of demand, and we just started putting things out there. And then we built models that basically use that past information to predict, like time series ones that would predict like when demand was going to come in. But a third angle that we came in from, which was one that I was actually the data lead for, was we brought in a lot of third-party data. And third-party data helps you a lot, especially when you're trying to get started and when you don't have a ton of data. So for example, we have a new census that just got completed and is going to be available pretty soon, and the old census data is still there too. So you can bring in a lot of information like that, like census data, like just like income data. There's a lot of different providers that give you things. Some of them are free. Some of them you can buy for like relatively cheap. Like the government has a lot of its own information that it just puts up for people to use. So you can bring in a lot of things from that as well to help you. It's like ultimately you likely have to build your own models or use some like model in a box type service. But the big thing about it is not going to be the sophistication of the model. It's going to be what data you input into it, because that's what sets the bounds of performance for a predictive model always. It's how good the data that goes into it is. So I would say, pursue a couple of different paths simultaneously. One, look into the model that you would have to build for something like this. And then the second one, start looking into third-party data that you can bring in that is going to feed that model and give you better information. So the census is like the most obvious one because the income and like population density and all of the information there is geographic, and it is like obviously going to be helpful, but there's other ones out there that you can find too.
Well, we'll probably be in the hand wavy, this neighborhood seems about right phase for a few more months, but we'll definitely look into that down the line. Thank you.
I mean, that's how everybody starts. That's always how it begins, and then you get into the bigger solutions later.
Awesome. Maybe time for one more question if we have one. I always just like to wait for the introverts in case someone comes in. Awesome. Well, I will send along the recording as well as Ali's contact info and anything else that he can provide maybe on the data roadmap as well. But just huge thank you